I'd like to welcome everybody to session 4 of the Get Set for Workboat 2050 sessions on behalf of the Commercial Marine Network and in partnership with Maritime Journal and Seawork and in association with the Workboat Association. This event is supported by the Society of Marine Industries, UK Harbour Masters Association and the UK Maritime Pilots Association. I'd like to thank our sponsors, Sea Machines. Sea Machines are the leader in the development of autonomous command and control technology and long-range computer vision perception for the maritime industry. By leveraging sensor expertise, artificial intelligence, and machine learning, they've created technology at the forefront of groundbreaking advancements in the maritime space. This is our penultimate session of the series. The next session featuring live and online in Seawork in Southampton in June. Now, in 2010, another of my company's masters working on another vessel was being audited by the management. And he openly informed the management that he had not taken the ship's computer out of the boot of his car for the last 3 months, claiming that electricity and water do not mix. Just over 10 years on, and I'm delighted to see where we are today as an industry. We have 3 fantastic speakers who are breaking boundaries and have fantastic experience to share with you to prove that autonomy and artificial intelligence do have a place in maritime. We apologise that during our last event, connection issues caused problems for some of those in the audience. We've run full trials this morning and believe that we've sorted all the gremlins as of before. But if there are any issues, please do drop us a message in the chat. We need to inform all delegates that the session today is being recorded, and we need to make you aware of some of the functions that are available. There is a chat function. This is available to use throughout the session, which we welcome delegates to use and make any introductions or comments. However, please do not use this function to ask questions. There is a separate questions and answers function, and this will give the opportunity for delegates to ask their questions to the panel, of which our host, Andy, will ask at the end of the session. Please type any questions in this section. We can't guarantee that all questions will be answered, and we can't guarantee that all questions will be asked, but we'll do what we can to try and pull close topics together. And if there are any questions that are left unanswered, then please reach out to someone after the session. So without wanting to hold today's session up any further, I'm going to ask Andy to join me. Morning, Andy, and introduce you to Andy Page from Chartwell Marine, today's host and moderator. Thanks, Andy.
Thank you very much, Kerry. Yes, good morning, everyone. As Kerry said, welcome to session 4. Today we are blessed with 3 fantastic speakers. Today the mission is that they're going to inform us about the work they're doing to deliver the latest in uncrewed vessel technology. It is my belief, and I think the rest of the Workboat Association would agree, that this technology has a huge part to play in our mission to decarbonise our sector, whilst at the same time improving operational safety. Each of our speakers today have operational systems which are active in the market, they're commercially available, and at the same time each company is consistently pursuing various R&D projects. So our first speaker today, if I could ask Liam to turn your camera on. Liam Campbell joins us today from SeaKit. Liam is the Commercial Director of SeaKit International. He's a chartered naval architect with over 30 years experience working in senior strategic positions for owners, class societies and shipyards in the UK, in Norway, the UAE and the Netherlands. As Commercial Director of SeaKit, Liam is responsible for identifying market trends and developing the strategic roadmap for the company. Liam's presentation today will look at the benefits of USVs for the commercial offshore industry, demonstrating how the technology is already proving its worth across multiple global projects. He will cover developments in over-the-horizon capability, satellite communications and connectivity, and in addition, Liam is going to present some idea of their future designs and propulsion options as we strive towards a zero-emission future. So Liam, if I could ask you to put your presentation up, we look forward to hearing from you. Thank you very much.
Good morning, everybody. Hopefully you can hear me loud and clear. My name is Liam Campbell. I'm the Commercial Director of Seekit International. Today I'd like to discuss the role of USVs on the route to net zero and how these vessels are already demonstrating efficiency wins on commercial operations around the world. The world's oceans cover 71% of the Earth. Ocean knowledge is critical to understanding our planet, and our future is linked to the health of the world's oceans. Yet today we know little about the ocean floor, with 81% still to be fully mapped. With the establishment of UN Sustainable Development Goals and initiatives such as the Nippon Foundation GEBCO Seabed 2030 project, we are seeing significant developments in technology, both in survey equipment and satellite communication, which is helping to realise these goals. The projected value of the hydrographic survey equipment market in 2022 is projected to be $2.74 billion, with an expected annual growth rate of 5.4%. In unison, the global underwater robotic market in 2017 was $2.5 billion, with an expected growth rate of 30.5%. This suggests that the survey equipment industry has taken up the challenge to innovate and produce high technology survey equipment for future mapping needs. The increase in demand for global connectivity means satellite communications has advanced rapidly in recent years. Vessels operating over the horizon are dependent on satellite communication on the ship's positioning systems, so the operators ashore can assess and send back to the USV the appropriate control commands. As the number of sensors increase, so does the amount of data that needs to be communicated between the vessel and shore. What is clear is that to advance autonomous vessels, there's a need for greater bandwidth and accessibility for maritime activities such as automation, navigation, and collision avoidance. According to the NSR, there will be 24,700 satellites ordered and launched in the next 10 years. SpaceX also has ambition to surround our planet with over 40,000 satellites. According to SpaceX, this will increase the internet speed up to 100 megabytes per second, allowing users to stream multiple high-definition movies simultaneously. SpaceX states Starlink will deliver high-speed broadband internet to locations where access has been unreliable, expensive, or completely unavailable. The global navigation satellite system is well funded, with a market size of $162 billion in 2019 and projected to reach $387 billion by 2027. If you consider the market size and infrastructure of the forecasted survey equipment and satellite communication industries, this suggests there's great opportunities to obtain large amounts of seabed data in areas we've not been able to access before, and even possibly live stream this information back to shore. So let's now talk about the third part, uncrewed vessels and their benefits. Of course, uncrewed vessels benefit greatly with reduced risk to health and safety, environmental impact, initial investment, and through-life support costs. If we consider the HSE, uncrewed vessels give an obvious reduction in health and safety risk to personnel. With the operators in a safe remote centre, uncrewed vessels can be operated where real-life decisions can be taken in a less stressful environment. The very nature of the USV means there is more sensors and technology on the equipment to gauge the performance of the vessels, allowing safety threats to be established faster and the suitable mitigation taken. If you consider the environmental impact, the size of the vessel to carry out the same operation is greatly reduced, hence there's a significant reduction in vessel pollution. As the fuel consumption is reduced to around just 5% of a crewed vessel, there is dramatic reductions in carbon emissions. This gives obvious cost savings. As the vessels can be smaller with no personnel on board to carry out the same operation, there is a significant lower capital expenditure and reduced operational running costs compared to your standard offshore vessels. With uncrewed vessels, operators control the vessels from the safety of the onshore remote control centre. For an OSV to operate safely and interact with other vessels offshore, operators need to have a sense of what is happening in and around the vessel. Rapid development of connected sensors and CCTV now allows operators ashore to monitor the vessel and the surrounding environments to make real-time decisions. As the vessel's autonomy becomes more advanced, allowing full monitoring of all systems, analysis can be conducted to determine trends and performance data and to further enhance efficiencies. We're already seeing a growing shift towards edge computing and the AI data processing, along with improved autonomous functionality and capabilities, including collision avoidance. So if we look at a simple cost comparison, using USV technology, of course, reduces the needs for vessels to be manned to the same extent. In a traditional vessel, the vessel design has to consider the safety and everyday needs of the crew, and this is a large part of the vessel's design. By being uncrewed and without the need to accommodate crew, vessels can be designed around the operational requirements, endurance and communication requirements instead of the safety requirements. This in turn makes operations safer, as well as allowing a significantly reduced cost in an extremely power efficient vessel. If we take, for example, a typical hydrographic survey vessel with a crew of, say, 66 people, to give you an idea of the cost savings, the cost of a USV to build and carry out the same operation is around 2% of a conventional vessel, with operating costs as little as 10%. The length of time to build a USV that can outperform a conventional vessel is a third of the time. So there's clear benefits from both the capex and operating models. So what does these figures mean? What are these, what are these actual savings? So if you take the above example of a survey vessel, and it's estimated that there is a £6,800 per day saving on fuel from a conventional vessel to a USV carrying out the same survey work. This equates to approximately £205,000 over a 30-day period. And if you consider a 6-month operating window, this is over £1.3 million per year. This is not even considering savings through reduced maintenance and personnel on board. The UK's emission reduction targets are driving considerable demand for net zero solutions. Maritime policy and regulations are focusing on reducing greenhouse gas emissions for the maritime sector. Targets from the International Maritime Organization aim to reduce greenhouse gas emissions by 50% by 2050, taking into account 2008 levels. As well as battery and solar panels, new fuel concepts are being considered, such as hydrogen fuel cells. And you'll see in the picture the one currently being developed by CKIT. Hydrogen fuel cells is not a new concept for land-based powertrains, but have not been used to any great extent in the maritime world. This has been mainly due to a lack of regulations and infrastructure, but this has been developed, and with the USVs being smaller vessels where safety and infrastructure challenges are reduced, there seems an option for hydrogen to be a viable fuel for USVs. In hand with the much anticipated advancements in technology and availability of satellite communications, uncrewed vessels are already out there and now ready to provide an important role in the future of shipping, bringing about faster, more efficient and safer marine operations. Thank you for listening. Back to you, Andy.
Great, thank you very much, Liam. If you wouldn't mind just staying on for a minute, got a few questions. I thought I'd start based on your background from classification societies previously. For people that are not so familiar with unmanned technology, what sort of testing is typically conducted prior to these vessels going into active service?
They carry out quite intensive factory testing, but of course there's quite an extensive sea trial program that takes into account all the different aspects of the normal functions of the vessel, but also takes into a large part risk assessments and safety cases that's been done in order to effectively make sure you have sufficient redundancy on all operations that you can carry out from a remote control centre that would effectively have been carried out by the crew.
So would you initially, during those trials, have people on board as well as in the remote control centre?
We do it in we do it in a controlled environment at first. We start some of the testing, but the majority of the testing is done without anybody actually on board. The earlier vessels, when we were just developing, we were a lot more cautious as far as that's concerned. But our technology has been developed so much now, we have a high confidence in it, so it's managed to speed up a lot of the testing.
Yeah, and I guess there's two levels of testing. Initially, there's obviously the operations of the vessel, and then there's the actual job that the boat is doing in terms of the survey work. So I guess there was, quite a bit of learning that had to go into transmitting that data to and from vessel to shore.
Oh, massively, and that is where I think Seekit are ahead of the industry just now, because we've got a very valuable partner in Fugro, and we've got vessels in service, and we've been able to get back that operational knowledge of fundamentally how the ship interacts with the survey equipment and what the threats are for the survey equipment in order to reduce any downtime or identify any safety risks.
And with respect to that safety risk that you mentioned there, how do you work with regulators to help them? It's obviously a novel market. I'm guessing you're working with them all the time.
Yeah, we're working hand in hand with the MCA and the Lloyd's Register. Of course, we have the unmanned vessel certificate. It was first in the world to receive it. We're very, very active with the class societies, and we see the challenges that the class societies and the regulatory bodies have, because it's okay to say that all the rules and regulations are for manned craft, so if it's uncrewed now, it must be easy. But it's not really as easy as that. If you look through some of the recent work they've done developing MSC papers, they have to basically troll through anything in excess of 50 or 60 different, historical, traditional rules and regulations, legal documents, just to kind of try and get a regulation written. So I think they have real challenges there, and it's a difficult process to speed up, because of course the technology is moving faster and the need for these vessels is moving faster. So I kind of feel a bit for these guys. They've got they've got a lot of work to do in quite a short period of time.
Yeah, quite. And I think, as you say, make sure that you support them and work with them is probably the best way to first and foremost make sure this technology is deployed at the rate it needs to be deployed, but also to help them to ensure it's done in a safe and pragmatic manner.
Absolutely. As I said, we've worked very closely with the MCA from the word go, and so we do understand their challenges. But we also, we try and clearly the USVs have to take a more safety kind of case approach to the development of them, and you have traditional maritime rules or prescriptive rules, and sometimes it's hard to kind of fit a square block into a round hole, but they've been, I'll be honest with you, they've been very, very open to new suggestions and understanding exactly how these vessels can provide a safe and efficient service.
And on just before we move on, a more frank question, which has come in actually on the panel, which could be quite fun. Has there been any losses of USVs or damage caused to the USVs during testing?
No, we haven't lost any USVs. That would be a disaster.
Yeah, an expensive day.
There's been, of course, part of the testing process is that you see, you're looking for failures. So there's, there is an element in the testing of it, but no, nothing that has caused any real great concern.
Thanks very much, Liam. We'll pick up a lot more in our panel discussion.
Thanks for the questions.
Yeah, no worries. Thank you. If I could ask Frank Rello to join, please. Great. So our second speaker today is Frank Rello. Frank is the Business Development and Commercial Manager of EMEA at Sea Machine Robotics. Frank has worked his entire 25-plus year career in the maritime industry and has been involved with commercial shipbuilding through to a career selling developed customized solutions within technology for many clients such as Damen, Van Oord, and IHC. The combination of advanced autonomous technology and maritime, along with being part of the global autonomous shift, is what has drawn Frank to Sea Machines since 2019. Today, Frank is going to present on today's artificial intelligence technologies and other developments, and how to navigate new oceans of regulations. The innovations of today drive towards Workboats of 2050, with the early adopters taking the lead in market share, meeting environmental regulations, and improving the life of seafarers. So Frank, if I could ask you to put your presentation on, and look forward to hearing from you. Thank you.
We work in an important industry, one that covers 70% of our planet and contributes to 5.1% of the global GDP directly, investing 1 trillion annually. So the oceans protect biodiversity and provide jobs, food, and drive economic growth, while keeping the planet cool and absorb about 30% of the global CO2 emissions. All of this to say the blue economy is an important one. With all the conversations taking place today around supply chains, congested ports, and the need to improve operation sustainability, workboats and the marine industry have come center stage. With that, so has the opportunity for optimization to reach our maximum potential, what we are here to talk about today, the Workboat of 2050. So the Workboat of 2050 will first and foremost be technology-driven, intelligent technology that enables connectivity, security, and enhanced operations and increased safety. That brings me to the main topic of my presentation, autonomy. So where are we with autonomy today? Human and machine relationship development, so not human versus machine. This is where we at Sea Machines are today, between level 3 and 4, automating highly manual, tedious or dull tasks that are often at the root cause of so many marine incidents. This autonomy can be used to support onboard or remote crews, or can provide fully autonomous unmanned operations in controlled domains with humans on the loop. Autonomy today is meant to support crews on board, not remove humans completely from the operations. So when will the industry start seeing autonomous vessels and ships as standard fare? The reality is that it's happening now. It's happening faster than it's for other industries, such as land transportation. Many early adopters in the commercial marine industry have already begun leveraging autonomous and remote control technologies for their vessels to improve operational safety, productivity, and predictability, while fully unmanned ships are still on the horizon. The industry will see a rapid uptick of autonomous and unmanned medium to large-sized workboats in the coming months and years. The result will be the start of an unprecedented era of safety, increased efficiencies, and the introduction of new skill sets for mariners. Autonomy is the ultimate utilization and optimization of technology, eliminating the costly, slow, and restrictive human touchpoints to allow for remote offshore or from another vessel control onboard systems, optimizing utilization of fleets and efficiency in operations. Sea Machines provide self-piloting systems with autonomous path planning and dynamic obstacle avoidance that allows for crew-supported navigation or remote command. These technologies are extensively tested in multiple environments on the world's largest autonomous fleet. This video is going to show you an autonomous cargo delivery that we have done in February last year. And basically what we want to show with this video is the technology readiness of the products we provide today. So we named it an autonomous cargo delivery just to give it a name, of course, and to show what the readiness is of the solutions. So what we see here is that our test boat captain is sending off an autonomous remote controlled vessel to have it sailing to its destination. So here we demonstrate again the technology while the onshore captain plans the mission via the user interface, as you can see on the top left. Cameras on the vessel provide the operator the necessary view around the vessel while the vessel is sailing the route with a minimum cross-track error. Collision avoidance is activated, and therewith able to avoid any kind of collisions according to the rules of the road, the so-called COLREGs. So the remote operator is able to adjust the speed of the leg and also adjust any kind of parameters during the mission, all done remotely while the vessel is sailing the course. We can now see on the screen an active collision avoidance. And the vessel is detecting another vessel. We need to give way to the vessel, and then on the bottom right you can see that a yellow box around the vessel means that our artificial intelligence, the camera detection, also knows what kind of vessel it is, and then is applying the rules of the COLREGs according to the deviating around it. So therewith we are running the mission complete and going further with the presentation. So let's dive deeper into the benefits the workboats of 2050 enjoy as a result of autonomous applications. This can be separated into 3 different buckets to simplify: productivity, sustainability, and safety. Autonomy provides connectivity and access to new forms of operational data that empower success in modern business and keep the industry competitive to expand into 2050. It delivers less human touchpoints driven by real-time analytical data. And it takes the continuous perception, routine navigation, and common decision effort that is no longer applicable to the 21st century human worker. Crews are then free to focus on operational tasks and leave the navigational to the machines. Autonomy optimizes engine performance and navigation, delivering efficiency and reduced emissions. The combination of increased productivity, safety, efficiency, and utilization will drive billions to the bottom line of the world's fleet operators while enabling them to lead with speed and agility. Think of it like this. Cruise control can help you become more fuel efficient and can help you save an average of 7 to 14% on fuel, thanks to its ability to maintain a continuous speed in comparison. The constant change in acceleration and deceleration driver consumes more fuel. Applying this to on workboats, it can lead to a 5 to 10% decrease in fuel emissions when you have that control. Then, and arguably the most important, is safety. Autonomous technologies feature active and passive collision avoidance. There is an inherent high risk at sea and high incident rates. Autonomous technology is ever alert and delivers predictable and operational results, eliminating liabilities caused by human actions. Using AI and computer vision, crews can avoid these dangerous scenarios, making the industry safer and more attractive for talent as well. So I'd like to bring you back to today, 2022. We speak of autonomy and the future of fleets, but what we often do not give recognition to is that these products are not something of the future. They are available today. So allow me to introduce you to our SM300 autonomous system, controlled onboard or remote, the SM200, the remote helm station, can be controlling the vessel anywhere outside the wheelhouse on board the vessel, and the new products that we bring to the market in 2022, being our onboard pilot assist system, is an onboard autonomous system, and our AI-powered vessel vision, or AICV, the beginning of the electronic outlook that we are going to provide to the market. The study shows that electronic lookouts provide more reaction time than looking out the window. The human can track maximum 4 targets if in the same vicinity, but not in different ranges, which the AI-powered vessel vision can. Taking a look at the technologies coming to the market and the implications. Intelligent technology utilizes machine learning, a branch of artificial intelligence and computer science, with focuses on the use of data and algorithms to imitate the way that the humans learn, gradually improving its accuracy. This comes in the form of autonomy and autonomous control systems. Again, these systems are not made to replace mariners, but at any means, but rather provide better decision-making abilities via better data and remove the costly human touchpoints. Touchpoints that lead to human error or costly environmental damage, all which can be avoided by embracing AI-powered technology. Operates better than the human eye can because it's never fatigued, never confused, and can give the attention to multiple targets across a wide field of view. Further to my point of these technologies and their availability today, their application has already been proven. I hope by now you have heard of the machine Odyssey, the first autonomous circumnavigation of Denmark, controlled from a command center in Boston. Take a look by the numbers. The SM-300 traveled just over 1,000 autonomous nautical miles. It took 13 days to collect 3.8 terabyte of data. 31 potential hazardous objects were avoided via collision avoidance maneuvers, and all complete with 97% of operations done autonomously. There was a crew on board, but rather than being stuck at the wheel, they were free to complete mission-oriented and high-value tasks. I hope you realize the Workboat of 2050 is something that we begin working on today. Thank you.
Thank you very much, Frank. Very, very informative. Super quick question. Is there any technology, and I think there certainly is, that UK operators running manned vessels could integrate today, perhaps in the level 1 or 2? I'm thinking the onboard pilot assist.
Yeah, correct. So yeah, that's something that we focus upon and that we work upon. So mainly what we do is install the systems on existing vessels as a retrofit or new build. And in that sense, work together with the people on board to improve their job and readiness level in that sense.
Cool. We'll definitely expand on that in the panel discussion. Thank you very much, Frank.
Thank you.
So Andy, if I could invite you to join, our last speaker today is Andy Tipping. Andy is the head of commercialization for Zealand. Prior to joining Zealand, Andy spent 8 years working in offshore wind technology development at the ORE Catapult, where he founded the industry-sponsored technology accelerator program, the Launch Academy. Today, Andy presents the adoption of unmanned rescue vessels, URVs, and shows that they not only improve safety for offshore operations, but also potentially unlock new ways of working. So Andy, if I could ask you to put your presentation up, we look forward to hearing from you. Thank you.
Yeah, thanks, Andy. So just going to start off with a short video just to introduce the technology and show you the journey we've been on. Brilliant. So yeah, that's just a quick whistle-stop tour on the different solutions that we've been working on over the last few years and what we're bringing to market. So today I'm going to be focusing on our next generation fast rescue craft, the Guardian, and what operational benefits that provides. So where we started out was with a problem, and that's the man overboard problem. And I appreciate many of you in the audience will be mariners, and you'll be all too aware of the issues of what happens when you fall in the water. The general rule of thumb is the sooner you can get somebody out, the greater their chances of recovering them alive. So in order to overcome that problem, how do you get to somebody quicker? How do you recover them quickly? How do you improve their chances of getting them out of the water? And what we saw was a limiting factor in existing incumbent technology. And the interesting limiting factor here is us, it's the human. The human doesn't fare too well in extremely rough conditions. And if you want to transit to an incident location, so somebody who's fallen in the water, you want to get there as fast as you possibly can. And if it's very rough, that could be a very rough ride. And if you're a rescuer, then you want to be alive when you arrive on scene, and you want to be able to perform a rescue, i.e. pulling somebody out of the water or doing some form of medical support. So if you're seasick or you've been thrown out of the boat on the way there, that's no good to you. So you have to moderate the speed, which means that you're going to get there slower. The other human limiting factor is the fact that you've got to get ready. The human has to get into the boat, has to put on kit, could be 2 in the morning, and could be rubbing their eyes, wondering what on earth's going on as the Mayday call has been sounded. And yeah, they have to get into the boat and off they go. So we're on a mission to make unmanned search and rescue a new normal and eliminate these limiting factors. So what have we come up with? So it's the Guardian vessel. It's a next generation FRC. And for the astute among you who would think, okay, well, normally on an FRC you would have medical support. So what we're looking at is a dual operation FRC, and this is something that can be both manned or unmanned. And the beauty of that scenario is that you can then decide based on the risk factors of the mission whether to send it manned or unmanned. So say, for example, it's extremely rough, and a lot of the crews for FRCs do their training in flat water, do a monthly drill, and then all of a sudden, you know, they're tasked to put their hero shirt on and go out in conditions they've never been trained in to go and rescue somebody. And in that scenario, you may just wish to send the robot. You may just wish to send the unmanned rescue vessel without medical support on board, and you could do that in an unmanned capacity, remotely piloted, and you eliminate the risk to the rescue crew, and that's a significant part of it. You can also then travel, it's not 30 knots, it's actually 35, travel at 35 knots to the incident location, arriving on scene quicker, potentially getting the person out of the water quicker. The operational limits this is being tested to is sea state 6, but that's just based on the tank test, well, the test tank capability. We actually believe we can go beyond that. The other interesting advantage here is your training. So the training for the pilot is going to be remote, so they can do that on screen. They're not having to do offshore drills all the time. And this is an interesting thing for FRCs because they are ubiquitous. You have the specialists who are on emergency response vessels who do this day in, day out and practice and do the drills. For the more standard vessels, you know, the likes of ferries, platform supply, etc., then the drills are less frequent, and the training, the people are not trained to the same level, and so their ability to respond to emergencies and to go out in challenging conditions is diminished. So those are the basic advantages from a risk perspective, from a cost perspective. Your OPEX is reduced. You haven't got the crew on board, etc. But what does that mean for the mothership? What does that enable? So if you have a mothership in field, say an offshore wind farm or an oil and gas field, they're able to provide emergency cover within a certain area that's time limited. It's based on how far the FRC can travel within a certain period of time in order to carry out a rescue. If the FRC can travel faster and can launch quicker, then the area it can provide emergency cover for, is extended. So where in the past you may have had two simultaneous operations going on, which perhaps was over the side working, and you needed close standby support, you would be constrained and you wouldn't be able to cover those two activities. If by extending that range, you could then cover further activities. So, you know, an ERRV or SOV in an offshore wind farm or CSOV could provide centralized emergency cover to multiple operations across the site. And yeah, the commercial benefits start to stack up quite nicely for that. What we're looking at beyond the next generation FRC is the opportunity to provide in-field emergency response. So that's having a permanent asset that lives offshore. And what this diagram shows is the position of national SAR assets against the position of offshore wind farms. And as you can see, the red lines show how far the SAR asset can travel in 1 hour, and the black line is 2 hours. So as you can see, a lot of the UK offshore wind farms are actually outside of an hour for search and rescue assets. So that's not ideal if you're going to fall in the water. So therefore, in-field provision is necessary in those scenarios. So what that means, obviously, from a health and safety point of view, is fantastic. You've got in-field provision, you can get people out of the water very quickly, and you can respond to emergencies very quickly. But what that means commercially is that you could have lone assets that transit to site, and then they would have emergency cover when they get there. So if a helicopter or a CTV or an SOV transits out to an offshore wind farm, they can do that safe in the knowledge that there is emergency cover for them and that they do not need to send a backup vessel. So that also the commercial opportunities stack up quite nicely. And just on a final point here, and this is a really interesting one, and not something that we were aware of until we started out on this journey, but offshore wind farms are built in grid patterns primarily to provide search and rescue lanes for helicopters to go and navigate in and out of them. If you had a resident infield system, then where we could respond to an incident, recover the casualty and take them outside of the wind farm for rendezvous with a search and rescue helicopter, then there is no need for the search and rescue helicopter to enter the wind farm, which means that you could actually design the wind farm in a different manner, which means that you could build it differently. This is a longer term play, but a very interesting outcome for search and rescue technology and the impact it could have. So that concludes my presentation.
Great, thank you very much, Andy. If I could ask Frank and Liam to rejoin, and we'll have a panel discussion on those interesting topics. Frank, if I could start with you, please. We started talking a little about how we could integrate into existing craft. How do you typically work with vessel owners or boat builders? What kind of information do you normally need to be able to sort of retrofit, as you described it, into an existing craft?
Yeah, interesting. What we need, of course, is the understanding, since we are controlling the engine and the shift and throttle and steering of the vessel direct with our system. Of course, we need to know the language that those systems are using. If the shift and throttle is a digital version or a cable version. If it's digital, what kind of language does it speak? And there we need to interface with. The good part of our system is that it is vessel agnostic. So with the installations we have done, we have already 30 different platforms used, meaning that we have basically seen all kind of propulsion, steering systems, and so on and so forth. Of course, we also need to have some information, so we connect to the existing radar on board, AIS, GPS, but also the echo sounder, for instance. So we just need to know what kind of language these things speak, and then we can interface with that.
So simply, would you sort of start at a basic level with a questionnaire or something, or do you physically do a survey on the craft? How do you sort of establish how
yeah, we do both. We start with a questionnaire. We have a standard form that we send to the operator, where they can provide the information about the engine, the steering type that they are using, and so forth. And if there is the chance to go on board, depending a bit, of course, where the vessel is, then we also like to do a vessel survey to see, to find a good location to install the box and to determine what is needed.
Okay, so principally the opportunity to fit some of this technology isn't too difficult.
No, it's to be honest not. It's quite simple in that sense. So if you have an electrician that is capable to run this kind of cabling and so on, it's quite easy to install and integrate. Correct.
Thank you very much for that. Liam, perhaps I could invite you to join the conversation. I'm interested, and it was actually a video that Frank played where we showed a collision avoidance. Although unmanned or uncrewed, is obviously clearly going to drive our industry forward in many ways. What shore-based jobs are going to be created and are already being created? And what type of person is carrying out these vessel manoeuvres? Because you've still got to be quite careful, even if you are initially in the early stage of autonomy driving it remotely.
Yeah, it's the current thinking and the current legislation. I don't think it will change. Basically, you still have to follow STCW, and you really want a captain to be with experience to be driving the vessel. I know that some people think it's great with anybody can sit down and do it, but you've got to have that sense of the sea and sense of how the vessel is actually responding. So I don't think there'll ever be a move away from shore-based personnel that have sailing experience.
And one of the questions that came in during the discussion was, do we anticipate one operator handling one vessel, or do we anticipate one operator handling more than one vessel?
It's a question that comes up a lot because, of course, companies are thinking more and more about trying to reduce further. What we've said is that it should be one operator per vessel. It's the law of the sea. It sounds great to have a multiple Star Trek type environment where you've got hundreds of things going on at one time, but fundamentally, the operator is so reliant on all the surveillance equipment and getting a sense of the dashboard, if you like, that personally I don't think it would be a good idea to have multiple or an operator looking after multiple ships. I'm not saying it can't be done, I just personally don't think that would be a good idea.
And Andy, do you concur with that? I mean, presumably the operators involved with the rescue craft not only have to be able to drive the vessel, but also there's a lot of other aspects going on.
Yeah, so I mean it's a fair point you raised, Liam, but in our case there are it depends on the operation. So for the fast rescue craft, for the Guardian, then you would have somebody who would be controlling it from the bridge or from onshore, and they would be a specialist who would do the regular training, because like you say, there are the additional requirements in terms of the human recovery, so enacting the rescue conveyor at the right time, etc. So there's that requirement. But the interesting thing for us when we're looking at that permanent standby capability is that obviously incidents are fairly rare. So you have a situation where somebody could be idle for a very long period of time. So there is something that there's some interesting models we're exploring around that shared asset operation, where you would have a pilot who would, this could work for, say, survey or non-safety critical tasks where you're doing perhaps open ocean survey work, and you could put the vessel into a holding pattern and then jump onto a rescue situation, as long as that could be done simply and quickly. And so you have pilots that are, they have their regular vessel that they're operating, and then every now and again they may get the call to just jump onto a rescue situation. They would be trained regularly for that, but it's something we're exploring at the moment.
Yeah, and presumably, Andy, we're going to need to, especially with unmanned rescue technology, we need to be able to find people. So presumably there's a lot involved in search and rescue, the different sensors, cameras, and how we're communicating that. How does that all work?
Yeah, so it's the fundamental challenge in search and rescue. How do you find somebody? And it's all well and good having good recovery systems and being able to arrive on scene quickly, but actually it can be extremely challenging. And especially if worst case scenario, they're not wearing PLB and it's they're in the woolly jumper and they've fallen overboard, and so we've been working on a system that uses a multi-sensory array and then fuses that into one. So for the operator, it's all about making it as simple as possible. And a point Liam made earlier in his presentation around the stress-free environment of remote operation and how that enables more clear decision making. So that what we've tried to do is design everything so that it's making the job as stress-free and as simple for the operator as possible, rather than having multiple screens, multiple controls. It's minimizing that to as far as we can, and having one screen where we've been developing autonomous detection of casualties in the water. So as you come closer to the incident location, the sensors will pick up that the person is in the water. A box will be drawn around that person, and the person will be tracked so that the vessel can navigate directly towards the incident location. And there's an interesting operating model around, with search, the higher up you are, the better. So there will be sensors on the ship's bridge. So if it's a mothership launched rescue craft, then you have the view from the ship's bridge, line of sight. And then you also have sensors on the vessel itself. But then there's also an option to send a search drone. And that's where you really get the gains in terms of search capability. And that, again, is fitted with the same SARbox technology, which enables that autonomous detection, which is fairly simple from overhead, because you don't have the issue of waves and things getting in the way. So we've been doing a lot of work trialing that over the last few months in operational environments, in nighttime, daytime, fog, mist, the whole works. So yeah, it's going to really change the game in terms of that search operation. And having humans with binoculars, that should be a thing of the past.
Yeah, and thanks for that, Andy. I, with respect to the technology there, Frank, you were showing almost the opposite, which is collision avoidance. But they probably are actually quite similar in what they're doing. It's just you're trying not to hit something rather than find something.
We're looking for people.
That's it, yeah. How have you developed that system so far, Frank? And I'm also interested in other technologies you might be integrating on board the vessel.
Yeah, well, thanks for asking. Well, where we started with collision avoidance is using the sensors that are on board the vessel, like ARPA targets and AIS. But as we said in the presentation as well, we are also going to integrate computer vision with that. So a perception system, a camera perception system that Andy referred to as well, is basically covering the aspect of people looking outside the window with their binoculars, but also able then to track, I wouldn't say targets, but objects in that sense, which are not recognized by radar or AIS. For instance, people in the water or debris in the water and that kind of stuff. So we are going to launch that as a separate technology solution that can be used as an additional sensor on board the vessels, but it will also be used for collision avoidance to be able to determine what kind of object we're trying to avoid. Because, of course, there are different rules applying to a sailing vessel as well to a power-driven vessel, for instance. But also you want to know if there is a buoy in the water or if there is an actual person in the water. So we see that technology coming in now. We have used the training on the AI with collecting all the data that we've done in several projects in that sense. And there we're now ready to launch this product to the market in addition.
Yeah, very interesting. I mean, one of the questions that's come in, as you'd expect, I guess, is how small can the system see? When we're in a big sea state, would a small yacht be able to be identified?
Yeah, it's of course, as Andy also mentioned, it's all depending on the height, of course, where you are able to position your camera in that essence. And then, of course, you will have some waves that might intervene with that. But to give an idea, what we have done some successful testing in locating a person in the water at 300 meters in front of the vessel. that was picked up by the camera as an object in that sense. But again, it differs a bit on the height where you can position the camera, and of course your sea state that you're in as well.
Yeah. Okay. And Liam, I'm interested. I mean, fundamentally, this technology is not boring, is it? It's quite inspiring and quite interesting. What kind of talent pool are you seeing coming into this market?
Yeah, it's very different. We have guys. We've actually invested quite a lot targeting computer programmers and guys that have a real interest. We've also targeted people who are well known in the robotics industry, working even in sometimes working previously on films and stuff. So it's bringing a lot of clever people into the industry, but I think the generation, I think the maritime world is ready for the new generation of people or younger people who are more used to working with computers and more understanding of how these systems work. So we're seeing a lot of software designers. Of course, it's great that we are designers and boat builders as well as advancing the technology. So we're seeing a lot of naval architects coming in that maybe wouldn't have the chance to see how ships get built in the UK. And designers, so it's a very interesting culture in that you have the traditionalist naval architects, and then of course you have the guys working on the technology that's continually challenging those concepts. So it's a very interesting.
Just looking at all your presentations there, I mean, we're seeing novel propulsion systems. We've got, I believe, stabilization systems fitted on some of these boats, multiple cameras, sensors, satellite communications. It's multidisciplinary, isn't it?
It absolutely is, and it's people immediately translate it to the car industry or the airline industry, and they kind of, the people who maybe have not been so involved in it just think the maritime world is maybe a little bit behind, but I don't think that's true. I think it's an incredibly complex medium to be working in, to trying to do it with ships, and I think that as people become more comfortable with that, there'll be lots of opportunities to do short duration shipping between different islands and to start to remote control and autonomize in small pieces. And I think that's where it is. But as far as, large tankers and expensive cargoes, I think there has to be a bit of a realization that maybe, let's walk before we kind of run, because you could end up picking all the credibility out of what isn't and get some that can really contribute to the industry.
Yeah, exactly. I'm very mindful of time, but I would like to, on the note of going bigger, as it were, Frank, perhaps you could, how big can we go?
Well, I would say that the system is basically unlimited in that sense. So we are working with small vessels. The majority of our systems are installed on smaller workboats, but it can go, let's say, from a 6-meter vessel up to I would say unlimited. We have done recently quite an interesting demonstration on a high-speed interceptor, 32-meter high speed, 50 plus knots, which was a challenging to apply autonomy on that, but that worked as well. And it's the same standardized, proven system that we use for all the applications. Is one system.
Yeah. And Andy, would you concur? And is it as Liam pointed out in his presentation, satellites are going to be our kind of critical in moving forward?
Absolutely, yeah. So what we're looking at initially is a fast rescue craft that's launched from a mothership, and in terms of control systems, it's the existing technologies are well and truly there. But when you move to over the horizon, and you're looking for, specifically in our application, that low latency to be able to do, recovery of persons from the water. That low latency communications is going to be absolutely fantastic for our sector and for the technology when we're doing permanent standby and over the horizon operations. It's possible now, but it's going to be a lot easier when those technologies become available.
Thank you very much. I wish we could carry on, and I think without speaking out of turn, I hope we can invite you all again next year, because it's a fascinating subject, and certainly really enjoying hearing how the technology is moving. Year on year, it seems to take strides forward beyond what we possibly thought was possible. So thank you very much for taking part. And Frank, thank you very much for Sea Machines in sponsoring today's session. We're very grateful. A recording of this event will be made available to all attendees over the coming days. Our next session will take place at SeaWork on the 21st of June 2022, and our topic will be hydrogen and clean growth opportunities. Is there a place for hydrogen in decarbonisation roadmap for the workboat sector? So thank you all very, very much. Enjoy your day, and look forward to seeing everyone at SeaWorks. Thank you very much.
Thank you.
Thank you all. Thank you. Bye.